Hi viewers, we have already discussed about the cross product and we have discussed the angle, how to find the cross product, the angle between two vectors and sign of angle between two vectors. Also the geometrical meaning of a cross product. Today I will solve some important problems of cross product and I will discuss about the important tricks also. Now here given the first question is a vector is equal to I cap plus j cap plus k cap and b vector is equal to 3I cap plus 5j cap minus 2k cap. Two vectors are given. The question is to find the magnitude of A cross B. A cross B as you know is a vector quantity. A cross B एक vector quantity है. So in order to find the magnitude of that vector, first to find that vector, पहले वो vector कितना है उसको निकालना है. इसके बाद हम देखेंगे उसका मैग्नीट्यूड कितना होता है. सो टू फाइंड फर्स्ट द वेक्टर ए क्रॉस बी, बट इफ टू वेक्टर्स आर गिवन देन ए क्रॉस बी कैन बी ऑब्टेन्ड इन डिटरमिनेंट फॉर्म. as you know a cross b, a vector and b vector are given. A cross b is the determinant. The first row is I j k. The second row is the coefficients of the components of a vector, that means 2 1 1, and the third row is the components of b vector 3 5 minus 2. And if we expand this, then this is I into minus 2 minus 5 minus 7 minus j into minus 4 minus 3 minus 7 plus k into this is 10 minus 3 is 7. So A cross B vector is equal to, we find, minus 7I cap, this is plus 7j cap plus 7k cap. This is A cross B vector. In this way you can find A cross B. Suppose तुमको टू वेक्टर्स दिया गया है, this is the method. यही है मेथड टू फाइंड द वेक्टर ए क्रॉस बी. बट हियर द क्वेश्चन इज टू फाइंड द मैग्नीट्यूड ऑफ ए क्रॉस बी. नाउ इफ ए क्रॉस बी वेक्टर इज दिस वन, देन द मैग्नीट्यूड ऑफ ए क्रॉस बी वेक्टर इज, as you know, this is 49 plus 49 plus 49 and this is equal to root over of 147. This is the value of magnitude of A cross B. Here the question is to find a vector which is perpendicular the two vectors. Find the unit vector perpendicular to the vectors this and this. Here two vectors are given. You have to find a vector which is perpendicular to these vectors. Then to find the unit vector which is perpendicular. Now interesting question. Look at here. The question is find the unit vector perpendicular to the vectors 2I cap minus j cap plus k cap and 3I cap plus 4j cap minus k cap. Two vectors are given. Suppose the two vectors are A vector is first one and B vector. Suppose these two vectors are denoted by A vector and B vector. The question is to find a vector which is perpendicular to both A and B. Then to find the unit vector. Now look at here. In order to find the unit vector perpendicular these two, first find a vector which is perpendicular to A and B. Now look at here. If A vector is this and B vector is this, a vector which is perpendicular to both A and B, I have already said in my previous class, a vector which is perpendicular to both A and B is A cross B. So here first we have to find A cross B. As you know, A cross B is I j k, then is the components of A is 2 minus 1 1, then is 3 4 minus 1, and this is 1 minus 4 is minus 3I cap, and here is minus 2 minus 3 minus 5 is plus 5j cap, and is 8 plus 3 is 11k cap. You know how to expand the determinant. If you expand this determinant, this is A cross B. So dear viewers, this is A cross B, means this vector is perpendicular to both A and B, but you need unit vector which is perpendicular to A and B. Look at here. This is A vector, this is B vector. A vector which is perpendicular to both A and B is in this direction. This is A cross B. But you need the unit vector perpendicular to both. Unit vector, that vector must be unit vector. तुमको एक unit vector चाहिए and that unit vector must be perpendicular to A and B. So that unit vector must be in the direction of A cross B, because A cross B is perpendicular to A and B. A cross B, A and B both को perpendicular है. तो A क्रॉस B वेक्टर की डायरेक्शन में जो यूनिट वेक्टर है दैट यूनिट वेक्टर इज परपेंडिकुलर टू A and B. A क्रॉस B is perpendicular. If A cross B is perpendicular, every vector has an unit vector. तो A cross B का भी यूनिट वेक्टर है and that unit vector is perpendicular to A and B because A cross B is perpendicular to A and B. So you have to find the unit vector perpendicular to A and B means the unit vector of A cross B, and that unit vector is the unit vector of A cross B is that vector by its magnitude. You know the formula for unit vector is the vector by its magnitude. So this is A cross B. Now magnitude of A cross B is root over of minus 3 square is 9 is 25 plus is 121, and this is 121 plus 9 130 and 155. This is magnitude of A cross B. So the unit vector perpendicular to both A and B is A cross B minus 3i cap plus 5j cap plus 11k cap divided by root over of 155, and this is equal to 1 by root of 155 into this vector minus 3i cap plus 5j cap plus 11k cap. So this is the unit vector which is perpendicular to both A and B. Now to find the sign of angle between the two vectors. Suppose the angle between these two vectors is theta. Suppose A vector and is B vector, angle is theta. You have to find the sign of angle between them means sin theta, and here sin theta, as you know the formula for sin theta is magnitude of A cross B by magnitude of A into magnitude of B. We have magnitude of A cross B is root over of 155 by magnitude of A. Look at here, A vector is this and magnitude of A is 4 plus 1 plus 1, this is root 6, and magnitude of B is here 9 plus 16 plus 1, and this is root over of 26, and putting here we get magnitude of A is root 6 into magnitude of B is root 26, and solve this to find the value of sine of angle between the two vectors. So this is the process to find sine of angle between two vectors. Suppose you have given, तुमको दिया गया है कि find the angle only, not sine of angle. Then if sine theta is this much, then theta is equal to sine inverse this value. So in this process you can find the sine of angle between two vectors or simply angle between two vectors. Another question is here, find the unit vector. Unit vector means vector by magnitude perpendicular to A plus B and A minus B, where A vector and B vector are given. You have to find a vector which a unit vector which is perpendicular to A plus B and A minus B. The unit vector perpendicular to these two vector means that vector is in the direction of perpendicular vector to these two. You want to find the unit vector. Now given A vector is a1 1 1, B vector is 1 2 3. So A plus B, we can find A vector plus B vector 2 3 4. A vector minus B vector is A vector minus B vector, and solving this 0 minus 1 minus 2. Next, look at here. You want to find unit vector perpendicular these two, but a vector perpendicular to these two vector. I have already said a vector perpendicular to A and B is A cross B. So a vector perpendicular to A plus B and A minus B is the cross product of these two vectors. That means A plus B cross A minus B. This vector is perpendicular to these two vectors A plus B and A minus B. So first find this vector. As this vector is perpendicular to both, then the unit vector in this direction is unit vector perpendicular to this A plus B and A minus B. So first find the cross product. A plus B cross A minus B, as you know, IJK in determinant form. First is the components of A plus B 2 3 4. Second is 0 minus 1 minus 2, and solving this you will get minus 2 I cap plus 4 j cap minus 2 k cap. So this is a vector which is perpendicular to both A plus B and A minus B, because this is the cross product of two vectors. Suppose this is C vector. So C vector is this, and C vector is perpendicular to these two. So you need unit vector perpendicular to these two, means that vector must be the unit vector of C vector, because C vector is perpendicular to these two vectors, but you need an unit vector, and the unit vector must be in the direction of C vector. In order to find that unit vector of C vector, first find magnitude of C, you know, and the magnitude of C is minus 2 square is 4 plus 4 ka square 16, and is 4 is root over 24 2 root 20 2 root 6. The unit vector perpendicular to both A plus B and A minus B is the unit vector of C, that is C cap. C vector by magnitude of C. C vector by magnitude of C. Dividing 2 root 6 on every component, you will get that vector is minus 1 by root 6 I cap plus 2 by root 6 j cap minus 1 by root 6 k cap. Next important but easiest question, to find the area of parallelogram where the adjacent sides of a parallelogram are given in form of vectors. Look at here. Obtain the area of a parallelogram whose adjacent sides are the vectors 1 2 3 minus 3 minus 2 1. A parallelogram is given. Two adjacent sides, suppose A and B, are given in form of vectors. So let the sides of a parallelogram are vectors A vector and B vector. Suppose this is A vector, this is B vector, and these two vectors are the sides, adjacent sides of a parallelogram. How can you find the area? Simple thing. If A vector is this, B vector is this, and these two vectors represent the sides of a parallelogram, then first find A cross B. A cross B in form for determinant, you know, IJK, components of A vector, components of B vector. Solving this determinant, you will find this is A cross B vector. If this is A cross B vector, then magnitude of A cross B, as you know, root over of 8 square 16, 10 square 100, 4 square 16, and this is root over of 180. But the area of a parallelogram is magnitude of A cross B. So area of parallelogram is magnitude of A cross B vector, and this is square root of 180 square unit. Always the area is represented as square unit. So in this process you can find the area of a parallelogram of any vector when the two adjacent sides are given. Now to find the area of a triangle ABC where the vertices ABC has position vectors 1 2 3 minus 1 minus 1 0 1 minus 1 0. Here the position vector of the vertices ABC are given. To find the area of a triangle ABC. Very interesting question. Given the vertices of a triangle ABC has position vectors as A 1 2 3, B minus 1 minus 1 0, C 1 minus 1 0. These are the position vectors of the vertices. But in order to find the area of a triangle ABC, you have to find the two sides as two vectors. But the two vectors must be co-initial. That means they must have common initial point. Suppose fix this point A and find the two vectors AB and AC. Now look at here, AB and AC are co-initial vectors. So first to find AB vector, then AC vector. AB vector is equal to B vector minus A vector. As you know, the position vector for end point minus position vector for starting point. AB vector is equal to B vector minus A vector. B vector minus A vector, and we find minus 2 minus 3 minus 3. AC vector is C vector minus A vector. C vector minus A vector is 0 minus 3 minus 3. Now to find the cross product of these two vectors, that means AB vector cross AC vector, in determinant form and solving this, you will get this is 0 I cap minus 6 j cap plus 6 k cap. If AB cross AC vector is this, the magnitude of AB cross AC is root over of 0 square minus 6 square is 36 and 6 square is 36. This is 6 root 2. But the area of a triangle is, if the two sides of a triangle are two vectors, then area of a triangle is half of magnitude of the cross product. So half of AB cross AC, half of 6 root 2, that is 3 root 2 square unit. In this process you can find the area of a triangle if the position vector of the vertices are given, or look at here, suppose the position vector of vertices are not given. You have given AB vector and AC vector. If the two sides of a triangle are given in form of vectors, then you can also find the area of that triangle. Sometimes what happens, student by mistake taking AB BC, AC CB also you can find. But if the determinant comes in negative form, if the determinant comes negative, but you have to convert it into positive, as the area cannot be negative. Also you can find the value will be same. Next is one important question. So that the vector area of a triangle, here we want to find the vector area of a triangle where the vertices of position vectors A vector, B vector and C vector. There are three vertices A, B and C. Position vector of these three vertices are given. Position vector of A is A vector, position vector of B is B vector, position vector of C is C vector. The position vector of three vertices are given, and to show the area of this triangle is half of A cross B plus B cross C plus C cross A. This is the vector area of triangle ABC. Look at here, if ABC has position vectors A vector, B vector and C vector, then in order to find the area, we have to find two sides as two vectors, and the two vectors must be co-initial. Suppose one is AB vector, another is AC vector. First find AB vector, then AC vector. AB cross AC, magnitude of AB cross AC, half of that AB cross AC. So ABC are given. AB vector is position vector of B vector minus position vector of A vector, that means B vector minus A vector. AC vector is C vector minus A vector. Now we have to find AB vector cross AC vector, and this is B vector minus A vector cross C vector minus A vector. Multiplying this we get B cross C minus A cross C minus A. here is B cross C minus B cross A minus A cross C plus A cross A, and this is B cross C. Look at here is minus B cross A, and we know minus B cross A is A cross B, and this is A cross B. This is A cross C. Minus A cross C means C cross A, and this is C cross A plus A cross A. The cross product of a vector with itself is 0 vector. So dear students, this is AB cross AC. Now area of triangle ABC is half of AB cross AC, and this is half of, we have to take the magnitude vector area. Vector area means half of AB cross AC, and half of AB cross AC is this. If we arrange this, this is A cross B plus B cross C plus C cross A. This is the vector area of a triangle where the vertices have the position vectors A vector, B vector and C vector. So if the position vectors of the vertices of a triangle are given, then you can find the vector area as this. Next question is, three vectors are given and are non-zero vectors, and these three vectors are satisfying A cross B is equal to A cross C. The question is to find the relation. What is the possible relation among A, B and C? Look at here. A cross B is equal to A cross C, which implies A cross B minus A cross C is equal to 0, which implies A cross B vector minus C vector is equal to 0 vector. So if the cross product of two vectors is 0 vector, you know, if two vectors are perpendicular, then dot product is 0. If the two vectors are parallel, then the cross product is 0 vector. Here the cross product of these two vectors is 0 vector. That means the two vectors are parallel, which implies A vector parallel to B minus C vector. So this is the relation among A, B and C vector. An important question is here, if A cross B is equal to B cross C, where C is non-zero vector, to prove A plus C is equal to M into B vector. Look at here, given A vector cross B vector is equal to B cross C, which implies A vector cross B vector minus B cross C is equal to 0 vector. Here is plus, so we take it to left side and become minus. Now is A vector cross B vector. Here minus B cross C means C cross B. Minus B cross C is C cross B is equal to 0 vector. And from these two, taking common B vector, we find A plus C cross B vector is equal to 0 vector. So what happens? The cross product of these two vector is 0 vector. If the cross product of two vectors is 0 vector, then the two vectors are parallel. So we find here A plus C is parallel to B vector, and also we know if two vectors are parallel, then one of them can be scalar multiple of other. So we can write this as A plus C is equal to scalar into another vector. Suppose that scalar is M, where M is scalar, and hence proved. Next question is to show that square of A cross B is equal to A square B square minus square of A dot B. This A and B represent the magnitude of A vector and B vector. Now from LHS we have square of A cross B, which is equal to A cross B means magnitude of A into magnitude of B into sine of angle between them. Suppose theta is the angle between them. A cross B is AB sine theta n cap and square of this, and this is A square B square sine square theta and is square of n cap. But we know the square of n cap, as you know, n cap square means n cap dot n cap, and the n cap dot n cap is a unit vector, and this is the square of magnitude and is 1 because n cap is a unit vector, the square is 1. So this is A square B square sine square theta is 1 minus cos square theta. So is A square B square minus A square B square cos square theta, and is A square B square minus this is square of AB cos theta, which is equal to A square B square minus this is A dot B. So A square B square minus square of A dot B. Again from this, so this question is proved. Now I want to add something here, but applying this property we can define the area of triangle in some other way. We know if the two sides of a triangle are given A vector and B vector, then the area of a triangle is half of magnitude of A cross B. Now look at here. Suppose A vector and B vector are the two sides of triangle ABC. So area of a triangle is half of A cross B, magnitude of this. Now delta squaring both sides. Delta square is equal to 1 by 4 square of A cross B. This is 1 by 4 into square of A cross B is A square B square minus square of A dot B. So look at here, this is delta square. Now area of a triangle delta can be 1 by 2 into root over of A square B square minus square of A dot B. So this is also the area of a triangle ABC. Now look at here, the area of a triangle can be obtained with the help of a dot product also. That means the area of a triangle can be obtained with the help of a cross product as well as the dot product. Another question is, A vector is given and B vector is given. Two vectors are given to show A cross B is perpendicular to both A vector and B vector. First to find A cross B. As you know, A and B are given. A cross B means the determinant, and A cross B is 10I cap minus 8J cap minus 11K cap. But we want to show A cross B is perpendicular to A vector and B vector. Two vectors can be perpendicular if their dot product is 0. So find the dot product of these two vectors. Now the dot product of A cross B and A cross B dot A dot B, 10 into 3, 30, minus 8 into 1 is minus 8, minus 11 into 2 is minus 22, and is 0. So the dot product of these two vectors is 0. That means the two vectors are perpendicular. So A cross B is perpendicular to A vector. Similarly, you can show A cross B dot B vector is 0. That means A cross B is perpendicular to B vector also. So I have already discussed the important questions of cross product. Thanks.